Okay, hello everyone and welcome to our channel Sumit Coaching Classes. As we had discussed, we are today going to have some problems, some CET problems, some NEET problems over the topic circular motion. Okay, so as you can see, I have written down the questions here. I have selected 10 MCQs, which are going to be quite useful for the students who are appearing for CET as well as NEET exam. So there are 10 selected questions which are on different concepts which will cover each and every aspect of circular motion very well. Okay, so let us start. So let me focus over the first problem here. The first problem is a body is moving along a circular path with variable speed. Now this word is important, variable speed. Okay, every problem contains a word which has a hint. So this is that word, variable speed. It has, so you have four options: a radial acceleration, a tangential acceleration, zero acceleration, or both tangential as well as radial acceleration. Now see, this is quite a simple concept, not a difficult concept. See, whenever a body is performing circular motion, okay, it has a fixed center, and let us say here we have our body. Now it has variable speed. It has variable speed. Now variable speed simply implies acceleration. Okay, and always remember, a body has two types of accelerations. One is radial acceleration, which is towards the center, which we denote by AR, and one is tangential acceleration, which is in the direction of the tangent, which is denoted by AT. Okay, so both of these accelerations are acting over the body, remember that. Now radial acceleration as well as tangential acceleration, these both accelerations act whenever we have variable amount of speed. Okay, so if you are given in the problem that the speed is variable, then always remember to select these both accelerations are acting over the particle. So this should be option D, both tangential as well as radial acceleration are acting over the body. Okay, I'll again explain why I did that. Because it has variable speed, it will have a radial acceleration also and a tangential acceleration also. Okay, variable speed first of all implies acceleration, so remember this one. Okay, this is the hint behind this one, so we have option D is the correct answer. Okay, now let us come towards the second problem. See, what is second problem? A body of mass 100 gram tied at an end of a string of length 3 meter rotates in a vertical circle and is just able to complete the circle. Okay, this is very important, is just able to complete the circle. Okay, if the tension in the string at its lowest point is 3.7 Newton, then its angular velocity will be. See, here some important terms have been given which you have to note down. Okay, so mass is 100 gram, which is 0.1 kg. Okay, you have to convert it into kg. Always remember to convert the quantities into SI units. Okay, otherwise maybe you will have a wrong answer. So always remember to convert all the things, all the quantities into SI. Then mass is 100 gram, which is 0.1 kg. I have written here. After that we will have a string of length 3 meters. See, string, if length is given, always take it as the radius. Okay, in circular motion, so radius is 3 meters. After that we have tension. Tension is given to be 3.7 Newton. Okay, tension is given to be 3.7 Newton. Now also G has been given. So first of all, remember, whenever you are solving problems for CET, just write down the given data first of all, because it will help you a lot to recognize the formula also. Okay, so I have written down the given data. Now see, a body is performing vertical circular motion. Okay, vertical circular motion, and what is asked? If the tension in the string at the lowest point here, okay, at the lowest point, see, tension always acts towards the center. Remember, tension always acts towards the center. So At the lowest point, tension is given to be 3.7 Newton. At the lowest point, tension is given to be 3.7 Newton. And what we have been asked? Angular velocity has been asked. Okay, angular velocity has been asked. Now see, it is quite simple. Angular velocity is omega. Okay, now we have been given tension, we have been given mass, we have been given radius. Okay, so now let us see which quantities balance each other. Okay, so here we have tension, okay, which is acting towards the center, and the quantities which balance the tension are the weight of the particle, that is mg, and the centrifugal force, which is mv square by r, and the centrifugal force, which is mv square by r. Okay, see, tension is acting towards the center. Opposite to that, weight of the particle will act towards vertically downwards, and the quantity which will add to the weight of the particle is the centrifugal force, okay, which is acting away from the center. So we can have the equation here, T equal to mg plus mv square by r. Now let us substitute the values. 3.7 is equal to, now m is 0.1 into g is given to be 10 plus again m is 0.1. okay, we can have v equal to r omega actually. Okay, but let us substitute it afterwards into v square by r is 3 here. Okay, so what happens? 3.7 will be equal to 1 plus 0.1 into v square by 3. Now let me shift 1 here, so we will have 2.7 equal to 0.1 times v square by 3. Okay, so this is my equation. Again, let me take it over here. So what will happen if I shift all the things? You will come to know that this is my v square. Okay, this will be my v square. 2.7 times 3 upon 0.1 equal to v square. Now if I cancel the decimals, then I get 81 equal to v square. Therefore my v is 9. Okay, therefore my v is 9 here. Now the problem is not yet over. We have to find out the angular velocity. Okay, we have to find out the angular velocity. Then for angular velocity, I will use v equal to r omega. Therefore 9 equal to 3 times omega, and therefore omega equal to 3. Okay, so omega is 3 here. We have option number B. See, as you can clearly see, we have option B here. Okay, so like this we have to calculate. Remember, I have written down the calculations. You can pause the video and find out what are the calculations. Okay, yes, now going to the next problem. Okay, so next problem is, a body of mass 500 gram is rotating in a vertical circle of radius 1 meter. What is the difference in its kinetic energies at the top and at the bottom of the circle? Okay, so for this you have to read the problem very carefully. A body of mass 500 grams is given. Okay, so mass 500 grams means 0.5 kg. So this is very important. Okay, first of all, convert all the things into SI. Then radius is 1 meter, it is given. Now see, it is performing vertical circular motion, and from the theory which we have discussed in our last video, we have discussed that at top position we have velocity, means minimum velocity is root 5 rg, root rg, and at bottom position minimum velocity is root 5 rg, right? So for using these values, we are now going to determine the difference between kinetic energies. As we know, kinetic energy is given by half mv square, right? So net kinetic energy will be kinetic energy at top position minus kinetic energy at bottom position. Okay, so which will be equal to half m into, at top position velocity is root rg, right? So v square will become root rg square, okay, minus, now here half m into root phi rg square. So this will be half mrg minus 5 by 2 mrg, which is equal to minus 4 by 2 mrg, which is equal to minus 2 mrg, right? Which is equal to minus 2 mrg. Now if I substitute the values here, okay, so let me substitute the values. So kinetic energy is minus 2 mrg, which is equal to minus 2 into 0.5 into r is 1 into g is 9.8. Okay, so this will become minus 2 into 0.5 is minus 1 into 1 into 9.8. So this is minus 9.8 is the kinetic energy. Now we have been given the options here: 4.9, 19.8, 2.8 and 9.8. So not considering the sign here, we have to just consider the magnitude, and the option is option D. Okay, so I hope you have got the idea of the problem. Okay, so this is quite simple, not at all difficult. Now moving towards the next problem. A body of mass m performing UCM. UCM is uniform circular motion. Remember, UCM is uniform circular motion with frequency n along the circumference of a circle having radius r. The force is given by. Now this is quite simple. Okay, this is quite simple. A body of mass m is performing uniform circular motion. Okay, see, remember, in circular motion only there are two types of forces. One is centrifugal force and one is centripetal force. Okay, you have to find out only the force. The force is given by. It has been asked that the force is given by. So you need not worry about centrifugal or centripetal, since these two balance each other, as we have discussed in the theory. So these two balance each other, and hence we are just going to consider the magnitude, which is given by mr omega square. Okay, f is equal to mr omega square. So this is the magnitude of force, remember that. Now we have just been given that frequency is n here and radius is r here. So I have taken the radius, no problem. Again I just will substitute omega equal to 2 pi n. Okay, we know this formula, omega equal to 2 pi n. We have discussed this in the theory. Students who have somewhat confusion here, okay, in some formulas, they have to just watch the video which we have made on theory of circular motion, then they will get the perfect idea. Okay, so just by squaring these terms I will get my answer 4 pi square n square. So let me write it as 4 pi square n square m times r. Okay, so this is my answer for force. Now let us check whether we have this option or not. Yes, we have this option here, option B. See, as you can see, there are 4 options: first, second, third and fourth. From these I will tick option B. Okay, so I think this is clear, everyone. The next problem. A car has linear velocity v on a circular track of radius r. If its speed is increasing at a rate of a meters per second, then its resultant acceleration will be. Now students, it is very important to know that the two types of accelerations are acting over a body which is performing circular motion, as we have discussed in our first or second problem. Those are, one is tangential acceleration and one is radial acceleration. Okay, so remember, resultant acceleration is given by square root of radial acceleration plus tangential acceleration. Always remember this formula. This is very important in the aspect of CET, since most of the times in CET these types of questions are asked. So this is important, remember that. So a is equal to under root ar square plus at square, that is square of radial acceleration plus square of tangential acceleration. Okay, now we have to just substitute the values, we will directly get the answer. We know that formula for radial acceleration is v square by r. Okay, this is very clear from the derivation of radial acceleration which we have discussed in our theory. plus tangential acceleration. It has already been given that the speed is increasing by a meters per second. So this is our tangential acceleration. Just substitute the value. So here we directly get the answer. This is our answer. A is equal to under root v square by r, sorry, it's bracket square, plus a square. So let us check whether this is option or not. Yes, so we have the option here. I'll just make a correction. It should be square. Okay, so this is option A. Yes, okay. So I have just used the formula and substituted the values, nothing else. This is quite easy. Okay, moving towards the next problem. A car is moving on a circular path and takes a turn. If R1 and R2 are the reactions on the inner and outer wheels respectively, then. Now see, this is very simple. Let us consider a curved path like this. Okay, let us have a car here. Okay, I have just drawn a box for you to understand. Now see, when a car takes a turn, this is a logical question. Okay, this does not need every time any kind of formula or anything. This depends upon your imagination also, so use your imagination too. Okay, so see, this is the car. Now when the car takes turn like this, it is obvious that people inside the car are pushed outwards. Okay, so the car slightly becomes like this. Okay, I have just drawn the shape for you to understand. Okay, so this is the inner wheel, this is the outer wheel. Now see, reaction is net upward force, right? So R1 is the net upward force acting over inner wheel, R2 is the net upward force acting over outer wheel. Now it is very obvious that the inner wheel is exerting more downward force, sorry, outer wheel is exerting more downward force as compared to inner wheel. So remember, by Newton's third law of motion, every action has an equal and opposite reaction. So more the downward force, more will be the upward force. Then if downward force of outer wheel is greater as compared to that of inner wheel, then of course reaction of outer wheel will be greater than as compared to inner wheel, and hence we should have this one. So this should be our answer. Okay, I'll again explain. See, outer wheel exerts more downward force. Okay, inner wheel exerts lesser downward force, and hence by Newton's third law of motion, action and reaction are equal and opposite. So R1, that is reaction of, or let us say reaction over first wheel, of course is less than reaction over second wheel. Okay, so R1 is less than R2. So here we should have option B, this one. So next problem, we have a car is moving with a speed of 30 meters per second on a circular path of radius 500 meters. Its speed is increasing at a rate of 2 meters per second square. The acceleration of the car is. Okay, now this is again a quite simple problem. I'll just tell the formula for you, and now I think you should solve the problem. See, we have been given radius is 500 meters. Again we have speed, that is velocity 30 meter per second square, sorry 30 meter per second. Again acceleration is given, which is tangential acceleration 2 meter per second square. Okay, so as we have discussed in our previous problem also, total acceleration is given by AR square plus AT square. Now here of course AR square will be V square by R bracket square, and AT square will be of course itself. Now I will just substitute the values and leave the problem for you to calculate. So 30 square upon here 500, its square, plus 80 square is 4. So this will be 900 by 500, its square, plus 4. So what is the answer? You have to calculate. Here 4 options have been given: 9.8 meter per second square, 1.8 meter per second square, 2 meter per second square, and 2.7 meter per second square. So it is up to you now. Okay, calculate the value and take the answer. Next thing, A car of mass 800 kg moves on a circular track of radius 40 meters. Okay, so let me write here, mass is 800 kg, radius is 40 meter. Okay, just write down the given things, it will help you a lot. If the coefficient of friction is 0.5, now as you know, coefficient of friction is denoted by mu, as we have discussed in our theory lecture, then the maximum velocity with which car can move is, see, I have given you the formula for Vmax already in the theory lecture. It is under root mu rg, right? So let us substitute the values. 0.5 into r is 40, and now let us take g to be 10 for our convenience. So this becomes 0.5 into 40, which is 20. Okay, and 20 into 10, or let us say 9.8 only. 20 into 9.8 here becomes under root 19.6. okay, I guess 196, sorry. So this is 14, of course, right? This should be 14. So what is 14? Meter per second velocity. See, I have just used the formula for Vmax, which is under root mu rg. I have just substituted the values and I have calculated the answer. So from this, as you can understand, mass which is given is of no use. Okay, so for your confusion, they will give some quantities which are of no use for your formula. Still, you have to just write it in the given one. Okay, so not necessarily every quantity which has been given in the problem should be used in the formula. Okay, so velocity of any particle or any vehicle moving on a curved road is independent of the mass. So remember, even if mass is given, you have you need not use it in the formula. So moving to the next part, a cyclist is moving in a circular track of radius 80 meter with a velocity of 36 km per hour. In order to keep his balance, he has to lean inwards from the vertical through an angle theta. If g is equal to 10 meter per second square, then theta is given by. Now see, most of the times for calculating theta, we use the formula of tan theta. But here, how can we recognize which formula is to be used? See, all the options are given in terms of tan inverse. So it is very obvious that we have to use the formula for tan theta. So remember these tricks also, okay? Because in competitive exams it is also tested whether you use a shortcut formula or not. It is not necessary to go by traditional way every time. So learn to use shortcut formulas also. Okay, so it is clear from the options that we have to use the formula for tan theta. We know that tan theta is v square by rg, which will become, now see again another point, v is given in terms of kilometer per hour. Now to convert kilometer per hour into meter per second, which is of course the SI unit, we just have to multiply by 5 by 18. Remember this one, okay? This is a shortcut trick. We just have to multiply by 5 by 18. So this will become 10 meter per second. Okay? So V is 10 meter per second. Just substitute the value. V square will be 100. R is radius here. Okay? So we have been given radius 80 meters. So 80 into g has been given 10. So this is 100 upon 800, which is 1 by 8. Okay, tan theta equal to 1 by 8, therefore theta is tan inverse of 1 by 8. Okay, theta is tan inverse of 1 by 8, which is option D. Okay, so theta is tan inverse of 1 by 8. Remember that. Okay, now moving towards the last problem of this session. A fighter aeroplane flying in the sky dives with a speed of 360 km per hour in a vertical circle of radius 200 meter. Weight of the pilot sitting in it is 75 kg. What will be the value of force with which the pilot presses his seat when the aeroplane is at highest point? Just imagine the phenomenon, okay? the pilot is performing a vertical circular motion with his plane. Okay, now the pilot is at the highest point here. Pilot is at the highest point, and at this point his aeroplane will be of course inverted. Okay, he is pressing the seat of aeroplane in this direction. It is obvious, right? Okay, it is obvious that he presses the seat of the aeroplane in this direction since the aeroplane is inverted. So see which forces are acting on the pilot. See, this outward force is given by mv square by r, which is centrifugal force. This is acting outwards, okay, and downwards will be acting the force which is his weight, right? So net force acting on the seat of the pilot will be mv square by r minus mg. Mv square by r minus mg. Why? Because this force is vertically downwards, this force is vertically upwards. Okay, so I have to subtract the vertically downward force from vertically upward force. Now just substitute the values and calculate the answer. You have all the values. Speed is given 360 km per hour. Again, for kilometer per hour we have to use this conversion, multiply by 5 by 18 and check out the answer. It will come to be 100 meter per second. Okay, again pilot's mass has been given, so m is there, v is there, radius r is there, 200 meters. You just have to substitute the values. Okay, so see, I'll substitute the values for you here. So 75 into 100 into 100, since it is v square, 100 into 100 upon r is 200 minus, again mass is 75 into g is 10. So this will become 2 zeros are cancelled, 2 ones are, 2 50s are. So 75 into 50 minus 75 into 10. Okay, so this will be 75 times 40, which is 3000. So 3000 Newton is the force which is acting upon the seat of the pilot who is sitting in the aeroplane. So let us check whether the option is there. Yes, we have the option 3000 Newton. Okay, yes, so we have solved 10 problems from circular motion which were of different kind of variety. Okay, so I hope this is helpful for you, and I urge all the students to again solve another at least 100 problems of circular motion so that they can succeed in CET. Okay, so thank you for watching the video. If you have not gone through the video of theory of circular motion, then go through it so that you will understand these problems better. Practice the problems very well. Don't forget to like the video. Okay, share the video with your friends and those who need the video, and don't forget to subscribe the channel and hit the bell icon so that you get the daily updates of our videos. Thank you for watching.